Hello and welcome to a Rogue Entity tutorial on PCG, Procedural Content Generation. We're going to start off by launching a project in 5.4.1, and the reason why we're using 5.4 is there's been changes to the PCG system since this version. In the project browser here, I think I'll set up, I might set up a first person different. Still going to make it C++. I'm going to add some starter content just so I've got some stuff to use, and we'll just call it PCG. I've got the generic first person template world here. I might just save this. We might come back to it, but at the moment I want to a landscape be more useful later demos. But I'm going to save this one so we can come back to it. I'm going to go new level. So I'm going to create a couple of folders here. I'm going to call one graphs, one blueprints. So we're set up now to do some PCG, and what we need to do is add PCG to the project. So I'm going to come up to plugins. I'm going to search for procedural. So don't search for PCG. If you search for PCG, you'll get the PCG plugin. You won't get all the other ones. So it looks like it's enabled already anyway, so it doesn't really matter. You can search PCG. So this is the framework one here, and obviously it's beta. It's going to tell you it's beta, and it is changing version to version. Like 5.4, there's been quite a few changes, and these other ones they sort of just give you nodes for other things. You might as well install them. It's only a few nodes. It's not going to break the bank. So once that's done, restart. So here we are back in the editor. We can begin using PCG. So PCG works so the goal of PCG is to spawn content procedurally, obviously, and it does that by generating points based off your world or whatever you tell it to generate off, actually. But the one thing to keep in the back of your mind is points aren't just a location in the world. They're actually, a point is a data set that has lots of other data other than a position or a transform. So, and you can add custom data to it as well, which we'll do down the track. But the points are generated by a graph, a PCG graph, which dictates the rules of the generation. So the graph will run and generate the points based on how you set it up. And that setup is done through a node-based system similar to blueprints in a PCG graph. So come into our PCG graphs folder. Let's just create a graph just to see what it looks like. So you should have a PCG menu now that you've got PCG plugin installed. And I'm just going to call this PCG example, and I'm going to just call this volume. I just want to show the different types of bounding that the PCG graph can use. So one is just a volume, and you see if you drag a graph directly into the map, it'll generate a blueprint straight away for you with like it's a brush component, but it's basically just a box collider, and this is the PCG component, and you can see our graph's been assigned to that. So let's not do an instance like this. Let's create our own blueprint. Let's go to blueprints, create a blueprint from an actor, and we'll just call it blueprint PCG sample 1. If we open that up, we just got a generic blueprint. We'll replace the scene just to get rid of this icon here. Place the default root there, and then we'll add the PCG component. So this is what we just seen. So the PCG component, and you've got the graph that we can assign there. We can assign that to our graph we just made. There's two that come with the project, including ones that show you how to do forests. that out. So now we need a bounds for it to generate within. So I'm going to add a box call. And we'll set this to something really large so we can see what's going on. By default, can change that whenever. And if we now drag in our blueprint, we get the exact same thing. Box collider, so brush, stuff that they use by default. And in our PCG, we should have our graph there. So we can't see anything obviously because the rules are telling it to do nothing, right? There's nothing in the graph. But if we open the graph now, we can begin generating points. So like I said, it's just like blueprints. You can see the nodes that are available here. There's a whole bunch of them, and you can do context search. So the first thing I'm going to do is we want to get the data from the terrain. So just type in landscape, get landscape data. So this will get the data that's within our bounding box, and we can do a surface sampler. We're taking points on the surface of the landscape. So if we come back to our open world here, we've still got nothing because we aren't spawning anything, right? So, but PCG comes with some debugging, and you can see the shortcuts here, but you've got D is debug, A is inspect. Let's just do A first, and he's still not showing anything, but if you have a look at the instance here, we can see we are getting points. We're getting 99 points. And this is what I was saying about points being data. This is all data on the point. Each point has all these variables on it. So now if we press D and enable debug, and you can see the tick box here as well, enable debug, it's all the same. So the shortcuts are D and A for D for debug and A for inspect. And if we come back to our world now, you can see we're debugging points. And the reason why they're a different color is it's actually assigning a debug. Debug color works on the density, showing you the density from 0 to 1, 0 being black, 1 being white. And that's just randomly assigned. And you can actually turn that off. So if I say points, apply density to points, if I turn that off, they're all white. So it's just applying all ones. You can see the density is all 1 now. The density is good because it allows you to apply some sort of random number to the surface, and that's the quickest way to filter the points. So if we go filter and do for a density filter, you can see the setting here is 0.5 to 1. So basically saying anything over 0.5 we want to keep. And with the and if I go back to the world now, there's no difference, right? So it's because I'm debugging at this point in the timeline of the spline. So if I add the debug over to here, you can see I've got 2. And this is not going to do anything because if I go back, I still can't see any difference because it's showing both. It's showing what this removes, and it's showing what was there before. So it's not showing anything. But if I take the debug off here, you can see it's removed all that are less than 5 density. So we've got some random points there to start. Before we go on with anything else, let's have a look at a different bounding type, which is line. So I'm going to create a new graph. Call it PCG sample. And I'm going to create a blueprint, and I'm going to just duplicate print. And in here, I'm just going to delete the box select, and then I'm going to add a spline. A box collision, sorry. Did I say box select? And now for the spline, we can set up a sort of a default spline, so add a few. And we want it to be a closed loop setting here. Just links the start back up to the end. That's our random spline. Can change that in the editor. One. And then come to our PCG and assign our line graph. Now if we come back to our graph, open up our line graph, to get the points in the spline, a little bit different. So we get spline data, which gets the spline from, gets the data from the spline, but by default what it does is, oh hang on, let's drag this in. So it'll get the points along the spline. I think if you do want that, it's called line sample. Debug that. You can see we're getting these here rather large and influence that, but that's not what I want to cover yet. So I want to cover using it as a bounding. So we're just going to get rid of that. And what we're going to do is create a surface from the spline. So create surface from spline. And then we're just going to do the same as before. We're going to do a surface sample. And then this needs a bounding shape. So if we come in, we're still not getting anything here. And we can get that by getting terrain data. So we'll do landscape, feeding that as the boundary. Now we have points in our spline. And if you change the spline, points regenerate to do that. And then from there, we can do the same things. One thing to note with the spline actually is the actor up, not doing our points. It's trying to, it has to intersect with the terrain, but what you can do, so if you come to the surface sampler, make sure if you do this on volumes, you're gonna fill in the whole map with points, but on this surface input here, you can do unbound and should open it. Right. So now, like when you raise it up, if it's not sitting perfectly flat, it's got the points still generated within the spline. But if you do want them on the terrain, so you don't want to be feeling around to make sure it's all, like all level, then you can just project the points to the spline after that. So. And I believe projection target is the landscape dragged in again. Now when I, maybe not, oh. And then make sure you move over your debug, otherwise you're still they were. And that projects them down. And so now it doesn't really matter where the spline is, as long as it's not under the terrain. Yeah, make sure we've saved all. So that's basic point generation in a nutshell. I'll just extend this to, actually I'll copy this, the density here, quick example, and then show you how to spawn a mesh. So static mesh spawner, and then you can come to mesh entries, add an entry, and PCG comes with some standard trees, poly trees that you can spawn. So I'll put that there and debug off. Back to the world, and I've got some trees, and I'll just aim in the other one. Trees here. So you can see it's random trees. It looks very linear, right? So just to show you how to use one more node, and change the, we want the transform points. Plug that in. In transform points here, we have all these settings of the transform, as well as an offset on the location. So we can set up randomization by setting the min and the max, and it chooses a value between. So for example, like if I set 360 here, it's going to choose a value between 0 and 360. You can see 3, but if I put the debug here, here, you can see that the actual debug points are rotated in random directions. And then the other thing I can do is an offset. So let's set it by quite a fair amount. And now we've got them offsetting, and we're running into a problem here where because they're offset, they're not using the generated point that they were given at the start, and they're starting to overlap. You could actually end up with a tree inside a tree. But what we can do is we can tell it to eliminate overlaps. Yeah. So after the transform, we can say prune, self prune. You can prune it by different data on the thing, but this extents will do the overlaps. Back in, you can see some trees have disappeared, so there's some debug points that are here with no tree. So I'm debugging before the prune, and there's less overlap on the trees now. Let's copy our setup there. Oh, actually, the last thing I want to do failed, so let's make it locked, so 0.5 on both. There we go, you're getting a bit more randomization now. And I think that'll do for the first video. So you've got some points, you've got some stuff spawning, it's kind of randomized. I think that's up. If you're a Patreon member, this project will be available on Git through Patreon at any tier, and it'll grow over time and hopefully resource. Thanks for watching, see you in the next video.